All right, welcome everybody. Let's continue. Here, for the next part of understanding the concept of a derivative, we have to be conscious about the idea of a secant line. So here, let's take a look. It says for this function, f of x equals 2x squared plus 4x minus 9. It says find the slope of the secant line between x equals -3 and x equals 2. So before we actually dive into what on earth is going on, visually we have to understand what's happening here. So let me see. What I did was, if you want, you could go to desmos.com. And if you go to Desmos, what you could do is we could get a visual of what this function looks like, right? And for the sake of everybody's time, what I did was I drew the graph right here. So visually, what's happening, and let me just focus this real quick. My bad. Okay, wait, my bad, it's focusing. Okay, so here we have this graph of 2x squared plus 4x minus 9. So this is the graph. Now it's saying find the slope of the secant line between x equals -3 and x equals 2. So if we take a look over here, let me just zoom in, and I feel like this is super bright. I have no idea. Wait, can I? Okay, that looks a little bit better. So here, we want to draw a secant line from x equals -3 to x equals 2. So just very quickly, what is a secant line? A secant line is a line that intersects two or more points on a curve. So if I have this curve over here, and if I have 2 points on the curve, this secant line just connects the 2 points just like that. Okay. Now here, notice that if at x equals -3 and at x equals 2, what we want to do is we just want to connect this secant line, right? So visually, this is what's happening, okay? This is what's happening. But now, what is the question actually asking us to find? It's saying, hey, what is the slope of the secant line? And notice that what we did before in the previous video, finding the slope was the same as finding the average rate of change. So notice that here, visually, we have a -3 as one of our x values. So we have an x sub 1, and now we need some y sub 1. And here we have some x sub 2. And what is our x sub 2 here? Notice that this x value is 2. This will be our x sub 2, and we need a y sub 2. Okay? So visually, what's happening is we need to find the average rate of change for this graph. But notice that given the question that we actually have, it's not giving you the visual. So here I was just very nice and I kind of gave you the visual of what's happening. But what we need to do right now is to find this slope. To be able to use this average rate of change, we need to find this y sub 1 and this y sub 2 within the graph. And let's imagine that we don't have the actual visual. Algebraically, how can we find, given the information, how can we find this y sub 1 and this y sub 2? And that's the question. What I'd like you to do is pause the video and try and think about, algebraically, given this information, how can I find what this y value is? How can I find what this y value is? Okay. So let's say you've thought about it. So here, quick question, what does the slope of a secant line calculate? Calculates the average rate of change. Now let's take a look at this question over here. What happens when we plug in a value of x into our f of x function? So here, if we have x equals -3, what happens if we actually try and calculate, let me get a marker. What is, if we know x is equal to -3, what does f of -3 calculate? If this is our x sub 1, to find our y sub 1, to find the y value that corresponds to this x input, we just simply plug in this -3 into this function, and it gives us this y value that we wanted to calculate. And we need to do that for 2 as well. So we need to find f of -3, and we also need to find f of 2. So if we know that f of x is equal to 2x squared plus 4x minus 9, what is f of -3? what I'd like you to do is, let's try and review our algebra concepts. How would you find what happens when you plug in -3 into here? Try it on your own, right? Okay, so let's say if you wanted to do it with me here, just double check. This will be 2 times -3 squared plus 4 times -3 minus 9. Okay, so now here, if you do 2 times -3, my heart will break, right? You have to do the -3 squared, which is, so it's 2 times 9. 4 times -3 is -12. This is -9. So now you have 18 minus 12 minus 9. 18 minus 12 is 6. 6 minus 9 is -3. So notice that when we plug in x equals -3, when we plug in x equals -3, what is that y value over here? It's also, it just happens to be -3. Okay? Now let's find the y value over here. So here, if we have x sub, so we know x sub 1 is -3, y sub 1 is -3. If we know x sub 1 is 2, given the information we have, we need to find y sub 2. And how are we going to do that? We need to find f of 2. So then if you know that f of x equals 2x squared plus 4x minus 9, we want to find f of 2. Let's see, this will be 2 times 2 squared plus 4 times 2 minus 9. And then if you, oh my bad, maybe I should have color coded a little bit here, right? Here, this is 2 squared, so this is 2 times 4 plus 4 times 2 is 8 minus 9. This is 8 plus 8 minus 9. So this is 16 minus 9. And then this becomes 7. And notice that, what does this 7 represent? If we look back over here, this coordinate value is 2, 7. So congratulations, we found the points. But let's recap. Why did we want to find these points? What's the actual question asking us to do? We want to find the slope. So we need our average rate of change. Now we have all the information we need. So this is our y sub 2, which is 7. So now just to finish up the problem, we have the change in y over the change in x, which is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So we have 7 minus a -3 over 2 minus -3. So then we have 7 plus 3 over 2 plus 3, which is 10 over 5, which is 2. So the average rate of change, or the slope of this line, of this secant line from -3, from x equals -3 to x equals 2, the slope of this line is 2. And that's it. That's what we wanted to calculate within this problem. All right, we're done. I hope this helped. I'll see you.